Welcome, everyone. Thank you for joining us for today's webinar. My name is Lori Jerome, and I'm the Marketing Manager for Premier Building Systems and Big Sky Installations. For over 65 years collectively, Premier Building Systems and Big Sky Art Control have been the leading manufacturers of structural insulated panels, also known as CIPs. Recently, the two companies have combined their technical knowledge and best practices, and together, we are the largest CIP manufacturer in North America. Today, we are presenting high-performance, healthy building envelopes for today's changing environment with Todd Bell and Patrick Chagru. This live webinar is approved by the American Institute of Architecture. So, a little housekeeping before we begin. We encourage your questions today, and we ask that you please type them in the Q&A section of your screen. We will review everyone's questions at the conclusion of the presentation. Our speakers are truly experts on CIP building and construction, and we encourage you to stick around if you have the time to participate in the Q&A. If you're taking this class for AIA credit and you entered your AIA number and certificate request during the registration of this webinar, your credits will be recorded and a certificate will be sent to you within 2 weeks. You will also receive an email with a recording of today's presentation and a link to a survey to review today's course. We would really appreciate it if you would provide your feedback and share your thoughts with us so we can continually create content that you find informative and educational. Now, without further delay, I will turn over the presentation to our two presenters, Patrick Chagru and Todd Bell.
Well, hello, this is Todd Bell. I'm going to take over the first half of the presentation, and then I'll be the click-through guy as Patrick presents the last half of the presentation. Today we're going to, and hopefully you see a beautiful picture of Patrick and myself, and some history on both of us. Today, just to kind of get through the registration stuff, this is an AIA continuation education series. We're going to get one AIA CEU credit, some copyright aspects. Course description. So we're acknowledging that we're living in kind of the new normal. Obviously, a lot of us are working at home. This presentation platform for us is fairly new. I'm used to seeing people's eyes and smiling faces and/or faces with questions on them. And of course, I can't see any of your faces or hear from you directly. So it's a little bit different for us, but we're still trying to get the information out and get people educated. CIPs create a virtually airtight prefabricated building envelope. This results in a healthier indoor environment. Through that, we meet a lot of the 2030 Challenge, LEED, Title 24, Clean Air for IAQ, and similar things through the building aspect here. So the learning objectives. After completing this course, hopefully we'll be able to explain what structural insulated panels are. We're going to give a brief description of the product. Second, we'll be able to define a high-performance building, key factors within the CIPs that we must target to achieve that high performance. Third, recognizing what makes the CIP envelope a better and high performance envelope. Understand the advantages of designing with CIPs. Understand the benefits of CIPs as we adapt to the new normal, and this is where it really gets into some of the social distancing and some of the stuff that we're dealing with now. And last, validate the performance attributes through actual high performance CIP built structures. So let's get right into it. Number one, we're going to explain what structural insulated panels are and how they're used. So what are CIPs? A couple pictures here, some installation videos. You see some panels being installed with a boom truck and or crane. Another stack of panels in the upper right as they're pre-stacked, prefabricated panels. CIPs are high-performance engineered components for walls, floor, and roof. Just the name alone, structural insulated panels. A lot of people say structural insulated panels or CIP panels, but true structural insulated panels. And how do we get that structural aspect, and what are those SIPs made out of? So the SIPs that we manufacture include OSB exterior facings. Certainly there are other facings that we can use. We've chosen OSB for some reasons that you'll see in some of the future slides. Then there's a structural adhesive. Of course, we laminate the OSB skins or adhesively weld the OSB skins to the foam through the adhesive. There's chases built into the foam. That's for your electrical, and that's at your traditional 1645, but can be put in special virtually anywhere you want based on the shop drawing phase, which will again be in a later slide. We've got the rigid foam control core, the EPS or GPS, and of course the interior facing. So of the three components, the first component we're going to talk about is the rigid foam core, the EPS or GPS. EPS is a fairly recognizable product, expanded polystyrene, whereas the GPS is a graphite enhanced polystyrene. Obviously, you'll note that it's a different color, gray in color. To go more specific into the expanded polystyrene facts, it's a permanent use plastic, and it contains no harmful chemicals, and that's obviously really important in today's climate. Materials are expanded and molded with steam only. Heat and steam is what we utilize to expand and or mold the foam plastic. Can be made with recycled material. Virtually all foam, rigid foam of the EPS variety can be, because it's basically expanded plastic, can be recycled. And there you go, recycled and reusable. Within SIPs, we try to use somewhere around 10% or less, just because of the bonding qualities and the structural strength that we're needing to get out of the foam, but 10% potential recycled content. EPS's construction design reduces carbon footprint. Now we're looking at the GPS foam. Basically, it's EPS with a graphite coating on each of the beads, and that results in a 20% higher R value than your standard EPS. Minimal cost increase, somewhere around 10%, so basically 20% better R value for about half the cost. So 10% more cost, about 20% more R value. Higher R values can allow for thinner roof and wall assemblies. Here in Washington and Oregon, codes can allow you to go from, let's say, a 10-inch roof assembly down to an 8-inch roof assembly. And you know what that does for you is, from an architectural level, gives you a thinner eave line profile, fascia line profile. Also gives you results in potentially less truckloads, reduced accessory costs, reduced connection costs, that kind of thing. Next, we have OSB. OSB is a renewable resource. It is basically a farm-grown type tree. So some of the things that it falls under are the TSCA, Toxic Substance Control Act, which it meets, the formaldehyde emissions. This is a very common misnomer in regards to oriented strand board, is that it utilizes formaldehyde-based glue products. That's about a 30-year-old statement. Most all, if not all, now OSB manufacturers do not use any products that have any formaldehyde emissions. Zinc borate is incorporated into the OSB. Zinc borate and frame guard, we can potentially treat the product, and this will treat it against termite and fungal decay. So it's not your old OSB. It's not your old chipboard that sometimes is referred to. Our OSB is uses a glue base that is higher tech, as well as incorporates zinc borate and frame guard, which gives it higher protection, less water absorption, so on and so forth. Made from fast-growing harvested species. as opposed to slow old growth coniferous species. Comes from, again, renewable resource. This is interesting that I learned that the net growth has exceeded net removal since 1952. So we're not adding to the greenhouse gases. We're actually, the growth of these trees is the net positive. Mills produce mainly through bioenergy, so they're using their waste product to facilitate the mill's energy use. Next, we've got the structural adhesive. We use a moisture-cured urethane type adhesive, so it has no off-gassing, no VOCs also. Similar to the glues that you'll find in engineered wood products, such as glulam beams, PSLs, LVLs. Once they are cured, they're not hazardous whatsoever. These adhesives become solid waste if disposed of also. SIPs replace traditional wall studs to provide a better R value. And so that's a big aspect, which the next few slides will talk about specifically, but the load is attributed and or facilitated through the skins, as opposed to a stick or stud frame cavity where the load carrying capacity is through the studs. Basically, by doing that, of course, you achieve higher R values and higher efficiency because those studs are thermal bridges and have a lot less R value. Many slides to come are in reference to that. SIPs are not prefabricated, pre-insulated stud wall panels. No common studs, basically. So reduced lumber does not mean less strength. Here's kind of a depiction of what SIPs can hold from a vertical point load, about 2,000, just over 2,000 pounds, where a standard framed wall capacity, because in a framed wall capacity, you're point loading specific studs. And or in this particular case, if you see the depiction here, we're point loading between a stud where basically there isn't a direct conduit and you're basically point loading a top plate, which then directs it down into those studs. Whereas with SIPs, you're point loading the whole wall assembly. So every inch or every foot of that wall is loaded equally. So here now we're talking about a uniform load in the same application. We can look at about 4,000 pounds per lineal foot, whereas stick frame applications are about half. Now let's talk about a little bit about the dimensions. SIPs are available in numerous sizes up to 8 by 24. That's the largest single piece or the largest single piece of OSB that we receive from the manufacturer. Nominal core thicknesses from 4-inch to 12-inch. When we say core thicknesses, we're actually aligning with dimensional lumber thicknesses. So when I say 4-inch, I truly mean that the foam core itself is 3.5-inch, 5.5, 7.25, 9.25, and 11.25, just like your traditional 2x, because we still have top plates, bottom plates, window and door wraps. SIPs are factory cut for accuracy, quality, and reduce on-site labor. You'll see how the panels are sold here. You know, you've got an 8 by 24 panel, but as far as how we sell it, it's similar to lumber in that we sell it on the 2-foot increment, whether that be a 4 by 8, 4 by 10, 4 by 12, and or an 8 by 8, 8 by 10, 8 by 12, every 2-foot increment. Ready to assemble panels are also available. So that is where we pre-install that lumber around the windows, around the doors, and any potential king and trim studs around header applications and or hold down applications. So this can be installed, the lumber that is in the panel can be installed in the factory. So it creates a ready to assemble panel that basically shortens your time even more on site for speed and efficiency. How do SIPs make a structure? Well, we replace the use of traditional framing products we create a set of shop drawings. So basically we take the architectural drawings and we create a similar set of drawings that show these SIP panels, the size of those panels, and how they mirror the architectural drawings provided. Once those shop drawings are approved, they go through, of course, a process of revision and redline. Once those are approved, we prefabricate the panels to your specific project, windows, doors, width, height, so on and so forth. Down here, you'll see a couple, 3 different applications, whether it be just a standard wall panel, one with a window and one with the door cut out, and then last, a window filler, one that would be below a window or door. Over to the right, you'll see a standard 3D view of a panel layout where I know it's small, but all the panels are detailed out as to size, length, and cut. And there's a finished depiction of that particular building. You know, you've got some odd angles, some radius cuts. Again, we're cutting it in a factory environment with CNC factory cut, so we can do some really unique and really intricate style cuts. Engineering and drafting are critical components to lead time with any SIPS product. You know, this is the most important part of utilizing SIPS is the shop drawing and engineering process. You know, education of the engineers on how to utilize the product, how to understand the strength, how to look at a wall assembly as a perforated as opposed to a segmented shear wall assembly, which is, again, you'll see later. Panels are sequenced to set in place like a jigsaw puzzle. Here's a little animation for you. Same thing goes for the roof. Set a ridge beam and start setting roof panels. Panels can traditionally span up to about 20 feet here in the Northwest, depending on snow loads, you know, and capacities. Again, in some of the future slides, you'll see, you know, a project going on the top of Snoqualmie Pass for the fire station up there. You know, of course, when you get into some excessive snow loads, that span is going to shorten quite a bit. SIPs serve as a turnkey structural and insulated high performance framing system. Replace exterior walls, floors, roofs. Large panels, factory engineered accuracy eliminates variations found in conventional lumber. And of course, we factory provide them with and double check through QC process, so you know you can rely on the accuracy of the product, as opposed to getting a truckload of dumped off sticks that may have a myriad of different problems. Incorporated air barrier through our installation process and the use of caulkings and of course the intricate product and just the way it is with the large OSB skins, the SIP tape that's used on the inside at the joints when we're done, it creates its own air barrier solution. Little or no drywall cracking because you have a lot less movement with SIP panels and of course a lot less lumber, which means that the swing of the moisture content in the material is a lot less. With a lot less swing, you have a lot less potential for drywall cracking, nail pops, those kind of things. Warranted unlike other framing products. There's a warranty slide coming up here soon. SIPs and roofs, attics, cathedrals, ceilings. This is kind of an interesting thing to note. A lot of times when a client wants that higher ceiling height, we automatically go to a 9-foot or 10-foot plate height. Nice thing about SIPs used in a wall and roof application is, of course, that pitch starts right at the plate line, as opposed to like a scissor truss or something where you have a lot lower pitch on the inside than they do on the outside. And it just makes the ability to use an 8-foot wall height more achievable. Of course, we can do a 9-foot, 10-foot, basically up to a 24-foot plate height if we wanted to. Again, up to 20-foot spans, large panels, fast installation. You'll see a couple pictures here depicting some very large panels on a flat or low slope roof application. Proven structural capacities. There's a series of code reports, whether it that show the capacities for span tables, shear loads, diaphragm loads, both transverse and axial load capacities. Can cantilever up to 6 feet depending on the loading. 6 feet is just a number that we've utilized and we've tested to, certainly from an engineering perspective. We can even cantilever further. You would just incorporate connections at the panel connections that would increase the ability to span further, maybe some engineered lumber, something to that effect. No drywall sag. You know, when gluing or screwing on drywall, you have a complete surface that you're attaching to. You're not trying to attach to studs and may or may not get that screw or nail into that stud. And the same thing goes, of course, for siding on the outside. The drywall and the siding application can become faster due to the fact that you're not searching or snapping lines for studs. Sound control and fire advantages. SIPs in an interior application can decrease your thickness. I'm going to just click down through these real quick. And they can decrease your thickness and still achieve your 1 hour assembly. So in this depiction, we've got a 4-inch SIP. We've got a couple layers of gypsum on both sides, assuming this is an interior common wall, and with a clip or channel. So you can achieve high STC ratings as well as your 1 hour assembly. Whereas in a stick frame application, of course, you'd have 2 framed walls, 1 inch or ½ inch airspace to achieve that same thing. So whereas we're, you know, somewhere net 6-7 inches, you know, you'd be in a stick frame application close to 10-12 inches. Some other recognized benefits: SIPs enclosures increase energy demand, they reduce the energy demand, excuse me, for heating and cooling. Kind of an obvious statement there. Some of the testing that we've had done through means shows about a 50% over stick frame construction. Can be installed, certainly can be installed a lot faster. Of course, they're bigger components, and a lot of the prefabrication is done in a factory environment. This is really important when you talk about jobs that have high labor rates. And I'm sure a lot of you say, well, wait a minute, all jobs have higher labor rates. Specifically, I'm talking about government jobs, prevailing wage, Davis-Bacon wages, where, you know, you're paying some fairly high wages. If you can basically displace some of those wages to a factory environment where we prefabricate everything in the factory environment, it can definitely be a cost reduction measure. Ideally, when you want to build to exceed current energy codes, if you're building to Energy Star or something that exceeds your standard Washington State Energy Code or Oregon State Energy Code, SIPs are an easy way to do that. Certainly, if you're looking towards zero energy or passive, SIPs allow you the ability to accomplish that easier. SIP structures are up to 15 times more airtight than stick frame walls. And we'll go into some slides that show you why. So next we're going to define some of the high performance key factors and targets to achieve this result. So let's first start by, you know, talking about what does high performance mean. You know, I'm sure it means different, you know, something a little bit different to everybody. The true high performance meaning that we've kind of zeroed in on means that a building that integrates and optimizes all major high performance building attributes, including energy efficiency, durability, life cycle performance, and occupant productivity. The key to constructing energy efficient enclosure is to minimize air transfer, hot to cold, or of course, if you're in a cooling climate, it would be cold to hot. There are three ways that heat moves that we want to discuss. Of course, first heat loss culprit is true air transfer. With the stud application, you have wall systems that have a fair amount of shrinkage afterwards and allow air in and around stud cavities. Your fiberglass insulation that is incorporated into a stud wall scenario allows for air, micro air around the bats and such. And then there's also convective looping. When you do have air that does get into those cavities, it creates its own convective looping. And so basically that's wasted or trapped energy that's in that wall that should be in your indoor heated space. Achieving high performance in a home and commercial building requires overcoming a number of construction challenges. Of course, air tightness, we talked about. Thermal bridging, we talked about. Moisture flow is important. Not only when we think about moisture, a lot of times we think about the moisture during the construction cycle or the moisture that gets on the material during that construction time frame. Of course, that's important, but we should also think about moisture flow from the inside to migrating to the outside. We create a lot of moisture as we're working in our homes, cooking, taking showers, so on and so forth. Proper material and equipment installation, and first cost calculators. All begins with the envelope. Using the UA alternative method, SIPs meet requirements for continuous installation with the 2018 IECC, reducing heat and cooling loss, again, up to about 58%, because they're more airtight. This talks about some of the specific California laws, which if you pay attention to how some of the code compliance works here in the Northwest, seems like it starts in California where they're a fair amount more restrictive. They've incorporated some air leakage applications. Certainly we have blower door tests here in Washington and Oregon also. They kind of take it to that next level through Title 24. What you're going to notice here is that SIPs meet some very high criteria in regards to air loss and air tightness. And they are actually pre-approved as a air barrier through Title 24. Third way that heat or cooling moves, which they say is the most stealth way, of course, is through thermal bridging. The picture up top you'll see is a depiction of a stud frame house. Yellow represents the major heat loss through those studs. A traditional Doug fir stud has about 1 R per inch of width. So a 5.5 inch stud cavity has an R value of approximately 5.5 inches. So every 16 inches, 24 inches in a stud cavity situation, you have a decrease in R value, of about 60-70% over what's in between those studs, which would be fiberglass in that application. Where with SIP panels, of course, the R24 runs more continuous. So here's some of the framing options. You've got conventional framing, you've got your standard EPS core, and then you've got your graphite core. I don't know if you've seen some of Sam Rashkin. If you haven't, I'd take note here. Sam Rashkin is with the Department of Energy, and he has some extremely good talks on SIPs, as well as efficiency, where we're going in the United States in regards to building technology and the use of energy and the saving of energy and the code changes and all that kind of stuff. Just a statement from him: SIP houses, of course, have fewer joints, less complicated interfaces between conditioned and unconditioned spaces. and it just makes the home tighter. We touched on moisture management. Moisture finds a path of least resistance. So therefore, fewer joints makes for a tighter structure in regards to moisture. Vapor drive can be a big issue, especially as we're building these homes more and more airtight. We need to be able to control the inside air quality and air management, and that's done through some sort of mechanical air, whether it's an HRV, ERV, something to that effect. Vapor barriers must be continuous, which of course is a challenge with stick-built. Properly sealed SIPs create a code-compliant air barrier with a permanent permeability rating of less than 1. It's actually 0.33 as a SIP assembly, so quite a bit less than 1. So materials and other things that we should be considerate of. Of course, the SIPs seal the airtight. SIPs achieve this. It's well insulated. SIPs achieve this. Much less required in the SIP structure. I've actually looked at homes that were designed stick frame where you literally do not have enough roof surface to eventually get that home to zero energy if that was an intent. In California, of course, one of the other things that Title 24 brings to the forefront is that all homes must be zero energy ready. So if you design a home that does not take into consideration some pretty aggressive energy efficiency scenarios, there's virtually no way to put enough solar on that roof to get that house to that level. Energy efficient heating and cooling, we'll talk about that in a future slide, where you can now incorporate things like ductless mini splits and heating and cooling systems that don't drain the pocketbook as much as your traditional forced air systems. Insulated windows and doors, so we should be considering also. A lot of clients are looking towards super insulated dual pane windows, of course, or even triple pane windows to get that efficiency up. Fresh air supply, I touched on this a little bit before, but one of the things we're doing here is we're focusing on controlling our indoor air quality as opposed to letting the fact that it's basically a windy day controlling our inside air quality. Efficiency for appliance and electronics. Here's how the costs stack up. And this is a interesting slide in that, from first blush, and this is where SIPs get a bad rap in regards to cost. At first blush, you look at SIPs from a cost material only standpoint, and it looks like we're more costly, and we are. When we stack up against just regular 2x studs, certainly SIPs prefabricated, of course, windows, doors cut to size are going to be more expensive, and then the time to do that. But then we start to look at installation. Installation, of course, is cut shorter because of that prefabricated component. We have the insulation, so you've got to subcontract somebody to come insulate that, and of course that's a time element where you've got to coordinate another subcontractor. There's a sheathing element where you've got to come and sheet the outside of that structure. Hardware element with hold downs and so on and so forth. Traditionally, SIPs, because they have a higher shear value, they have a higher axial and transverse load value or capacity. The hardware could be a little bit decreased. The exterior finishes, again, we talked about the fact that the sheathing is continuous on the outside and inside. No searching for studs means that nailing on things like siding can be done a little bit faster. Same thing with the interior with the gypsum. HVAC heating requirements. I think this is, for me, this is a really big one. We had many slides that talked about the efficiency from an R value standpoint, but how does that equate to cost? Well, it equates to cost because a traditional heating system, a forced air heating system, is going to run you about twice that of some of the more efficient heating system, the ductless mini splits, that kind of thing. General conditions, waste and disposal. Of course, we're not going to ship you the window or door cutout. When you get a stack of studs and you start, cutting studs to length and framing a structure in the traditional manner, you create quite a bit of waste. Cost of money, if you can shorten the time cycle of constructing this home, certainly you can save some money there. Callbacks, lost revenue for time. Obviously, if you're a contractor and you can build that house faster, that means you can get your revenue stream onto the next house. And just a better product, the resale value. And then the big one again is operating costs. You basically, once you've done all these things, you've got a lifetime to realize the efficiency and put money in your pocket over a less efficient, more costly heating and cooling system, or cooling home. We're going to click through some of these next slides fairly quickly because I'm running a little bit behind. Sorry for being fairly talkative here. So this is just an average California home, talking about the overall savings based on the speed of construction, the insulation savings, and framing costs is what kind of kicked this one into being an overall savings. And this, of course, does not include the energy aspect. Does not include tax incentives. I think that's the first time we've mentioned that. One of the benefits of CEUs is it does qualify for the tax rebate program for energy efficient homes, and that's obviously super important because it's $1,500 up to $2,000, I think, in some states. So example does not include a layer of continuous insulation now required under Title 24. Also in Eastern Washington, and in that particular zone, we typically see in Washington State Energy Code R21 +5, the +5 meaning an inch of rigid insulation on the outside to give you that continuous insulation, not needed with CEUs. Couple life cycle assessment statements. Energy payback. Recognize what makes a SIP envelope better, high performance solution. Again, here are some of you'll just see that SIPs have in regards to thermal bridging, how a traditional SIP home works in comparison to a stud frame cavity. So here's some of the different R values. The gray represents the GPS values. The white represents the EPS phone values for the different. One of the things you'll note here is that as the temperature decreases, the R value actually increases because the inside air temperature, or because the outside air temperature gets more dense, and the encapsulated air into that foam panel, into that EPS stays the same. It actually increases R value as the temperature decreases. This is a good Oak Ridge National Laboratory study. Just real quick, shows that even a 4-inch SIP wall outperforms at R15 a 6-inch stud wall. So, obviously a 6-inch way outperforms, but even a 4-inch wall, the insulation value at 14 on a whole wall scenario outperforms the 13.7 of a stud cavity wall 2x6. Some of the environmental performance stuff that we look at. Performance metrics, HERS ratings, AIA CEU max air leakage standards. Department of Energy has waived the requirement for blower door tests with SIP structures. That's a big one because, of course, blower doors cost money. Over a third lead points can be associated with the use of SIPs. If you haven't started talking about HERS rating, this is how a lot of homes are evaluated nowadays. A lot of existing homes are at around a 130. New standard home, they want you to get it to about 100. SIPS homes are, 30, 40% more efficient than that. So each point decrease in the HERS index corresponds to 1% of energy reduction, whereas a zero energy home, of course, would be 0. Again, another statement on blower door. LEED, max 30 points. Here's some pretty obvious point structure. FSC certified OSB, construction waste management, low emitting products, proximity of materials manufactured to job site is important, that kind of thing. It's also a warranted envelope. One of the things you do not get out of a stick frame application is a warranty. SIPs provide, most all SIP manufacturers provide a 20-year warranty on the product, both for their lamination as well as their R value. Now we're into learning objective 4, understanding the design benefits. Any can be used for any type of type 5 residential commercial building, as long as it's type 5 wood-based construction. Large spans can eliminate truss requirements, support in-plane and in-plane loads, shear and diaphragm, transverse loads.
Okay, would you like me to take that?
I think you're at 5, right? Or are you now?
Yes.
All right, go for it, Patrick. I'm going to be clicking for Patrick, and he's going to.
Well, actually, we got it fixed, Todd. So if you'll just relinquish the control, I'll share my screen.
Stop share.
And we'll do that one more time. Okay, we're going to go over the advantages of designing and building with SIPs. However, we do value your time, and I see we're running short, so I will go through these rather quickly. So as Todd touched on, they can be used for any type of type 5 residential, commercial, or institutional. This was touched on a little bit, but it's a real key feature with SIPs. You're all familiar with segmented shear walls, lots of hold downs, lots of lumber. And if we keep putting all that lumber in there, we're not going to get to the high performance we need. So with SIPs, we typically design it as a perforated shear wall, so the whole wall is considered in one piece. Of course, you can and do need to use hold downs, so we try to use the strap hold down on the right as much as possible. The HTT or HDU type is also easy to use with SIPs. Headers are a big consideration because, again, we're trying to take as much lumber out of the assembly as we can. On the left, the panel itself can act as the header. If we do have a load that needs more than just the SIP, we can use our insulated header. Or if it's even longer or needs more load carrying capacity, we can use LVLs or glulam's. Let me back up there. That's another important one. All the lumber that's required there to carry the load around the opening can be avoided with SIPs. We just use the skin to carry that load. A couple details. We've got a block spline, which is our go-to connector. It has the least amount of thermal bridging. And corners, it's like a high performance framing system with only a two-stud corner. If we have to go to a I-joist to get longer spans, we do that. And makes a great connector, again, with minimal thermal bridging. For the contractor, much faster close-in, fewer laborers, or at least trained laborers. And again, the reduced HVAC. Factory built reduces the job site waste and reduce callbacks. If we're going to try to produce a high performance wall system with SIPs, it's going to take a lot of layers to do that, which means time and money. With SIPs, you stand them up, wrap it, put on your siding. Lots of advantages here. Typically a 4 or 5 person crew, a couple guys prepping, 2 guys standing, and 1 person putting the sealant or running around getting other materials. And we all know what the problem with the skilled labor shortage. And with fewer people on the job, we can achieve our social distancing easier. Recently did a apartment building in the Spokane area, and it was nice to see all those windows line up from floor to floor. My son owns a cabinet shop down in the Salem area, and he's well aware of the problems of trying to put cabinets up against stick frame walls. We've covered this before, but it's a big one. Just the cost savings there can add thousands of dollars to a job. Of course, we're often asked about electrical. The chases are built in. Standard outlet height, switch height, and vertical 4 feet or as required. I do have a video here, but I'm going to skip through that, and you can find that on our website. And that's the link there. Go to Premier SIPs, resources, and videos. Okay, how do SIPs help with the quote unquote new normal? As we social distance, more people working at home, how's that going to affect how we design and live in our homes? With people being there more, we're going to have a home that's tighter so that we can control ventilation rates and control other things. Of course, the health and wellness is a big one. That's going to include cooking and kitchen design changes, home health care, fitness, home gyms. They were already becoming a factor for larger homes, but we may have to think about that for most homes now. And of course, smart home technology. Are we going to need a special space for offices? Is that going to require another building in the backyard or doing something in the garage? More flexible spaces for cooling. We're going to need more outlets for high-speed internet. Are we going to need to add on or do other things for energy and food storage? We do actually get healthier indoor air. Again, people think that OSB is the old flake board or something, but there is no VOCs in our system. The zinc borate that we apply, or is it actually built into the mat when they make OSB, can help keep molds from forming. As we all live more indoors, we need to control it. You can't control it if the house leaks like a sieve. So with less people on the job site, get it done quicker. Okay, we're going to look at some actual validated systems here. And we understand if you need to go, this will be recorded and you can pick this up at a later time. And I do see we have some questions, so if you can stick around to the end, I will try to get this finished up. We don't make up these numbers about how quick it goes. RS Mean did 2 houses side by side, came up with a 55% faster. This would be fun to run all the way through, but because of our time, it's a large commercial building. Here's a 000 energy home built with SIPs, Green Builder of the Year, some school projects. So these SIPs are not just relegated to the residential market, but everything from tiny houses on wheels to larger commercial buildings. Here's some examples of schools that have been built with SIPs. Some homes. Another net zero green energy builder or Green Builder of the Year award. Commercial projects. We're working on some 7-Elevens right now. Some big public buildings. Fire stations. People often think that SIPs are a fire hazard. If they were, they wouldn't have been used in. I can think of 10 or 12 fire stations that have been built with SIPs. So hopefully you've learned these objectives today. And we're here. You can learn a lot of this on the website. Give us a call. We'd be glad to work with you. And as you're going through your design projects, hopefully you'll see some that might make sense for SIPs. Give us a call. We're glad to take a look at those and see if it is a viable opportunity for you. SIPs are the easy and fast way to get to high performance. And I'm going to take a look now, or maybe Lori, you can do that. And see.
I've been typing a few of the answers, but I've got, and I think everybody will get that in the form of my typing them. But there is 4 still here, and I can address those really quickly. And a lot of these are, similar. They're, really in regards to moisture. And how to protect that exterior skin. As of recently, in the last few years, we can actually paint the exterior skin if you're in a commercial application where, you have longer than usual exposure times. Remember, we're using OSB that is not your run-of-the-mill OSB. It's got a ZB additive into it, zinc borate, which deters water absorption and fungal growth. But in addition to that, we can paint on, most commonly we use a product called Stowe Gold Coat, which is a WRB that can be painted on in the factory, which basically makes it similar to the zip system that a few of you commented about. What are some of the best siding, cladding materials to use with SIPs for maximum energy efficiency? Once you've established that you're utilizing SIPs, virtually any type of siding can be used. Of course, some of the underlayments may change based on whether you're using, hardy type system as opposed to a cedar type siding, that kind of thing. But any type of siding system can be used. If you want to take it to that next level and truly create a CI or a continuous insulation envelope on the outside of the panel, certainly there are siding systems that have even an additional layer of insulation attached to them. The next one is, do roof panels also have chases for lighting? Yes, of course. We can incorporate them. What we traditionally would like to do is incorporate them during the shop drawing process and put them where you need them. But we can also put them in a standard array where they're there regardless of whether you need them today or 20 years from now, if you're adding or subtracting some sort of electrical lighting, hanging fan, that kind of thing. Is there any way we can get access to this slideshow? Yes, absolutely. As a matter of fact, Lori here, who's our moderator, will be emailing you, every one of you, a link to the slideshow where you can cut and paste and take slides out as needed. So you'll have access to that slideshow. Is the FrameGuard OSB treatment applied to all SIP skins, exterior and exterior, by default, or is it an upgrade option? It is currently an upgrade option. We are toying with the idea of providing that as a standard, a standard product. Unfortunately, of course, there's a cost associated with this, which is why we are looking at it as an upgrade option currently. Is it possible to use SIPs for a floor system? Of course, yes. In a floor system application, just give you a couple examples. Up in northern climates where you're on pilings, it worked really well because SIPs are, of course, sheeted on both sides and you don't have insulation falling out. You don't have, problems with varmints getting up into the insulation. Down here in Seattle and Washington, Oregon area, of course, there's pin pile applications, and or because of the new tiny house and ADU applications, a lot of people are building new homes in backyards where they're using a sonotube style foundation with a grade beam application, and those are perfect applications for SIP floor systems. How do you deal with drain plumbing when the SIPs are used as a floor in the second story? Well, there's a clarification there. When I said SIPs are used in the floor, they're used in the floor for a SIP envelope. Traditionally, we would not use them between floor systems. There'd be no true reason to insulate the first floor away from the second floor. Of course, there's always specific applications or something that may be special, but traditionally, we do not utilize SIP floor systems on in-between floors, just like we wouldn't use them for interior walls. Plumbing and electrical seem to be drawbacks in terms of prefab aspect. Can we talk about that? Yeah. Your electrical is all prefabricated with electrical chases. In special circumstances, we can even cut out your electrical box locations. So we can make it pretty easy for your electrical, installer. As far as the plumbing goes, your hot and cold water supply should be brought up through the floor system. And really the only thing we should be accommodating for in an exterior wall application is the venting. And that's pretty easy. It all goes back to an acronym I like to use a lot, which is prior planning prevents piss poor production. As long as we kind of work through that through the shop drawing process, it can actually be quite quicker. Can we do an exterior wall 24 foot high? Yes, in theory, absolutely. Are the transverse loads and wind loads exceeding what we can do as a deflection factor, though, is the common question. A 24 foot high wall is great, but of course we want to put windows and doors in, which of course weakens that wall. And at some point, we don't have enough transverse load capacity to allow that 24 foot tall wall. So yes, we can. It's kind of an engineering question. What sort of accuracy can we expect over a 24 foot long with windows, etc.? We are currently, and we will have online, most likely a video of us installing our new CNC router. We currently have a CNC router which can cut to within a 32nd of an inch, and it's extremely accurate. The new CNC router that we have that is literally in the port in LA right now will be installed next month, and it'll even take that accuracy up further. So the accuracy is going to be, as best as can be done with a CNC factory computer aided router machine, basically. So extremely accurate. Last we have, do you usually need to cut the glass panels per wall to size? How is this done in the field? It depends on the length of that wall and whether you have any growth through the process. During the shop drawing process, we actually incorporate expansion and contraction growth joints. So basically between every panel, we incorporate 1/8 of an inch for expansion contraction, just like you would in a roof sheathing of a sheathing on a roof over trusses. That being said, depending on the time of the year and if the lumber or something else is growing, yeah, you can be at a potential to cut that last panel, you know, cut 1/4 an inch off or something to that effect. It's fairly easy. A lot of times they won't even cut it. They'll use a hand power planer or something to trim off that 1/8 of an inch or 1/4 of an inch if you're getting it that close at the corner element. I think that's it, Lori, as far as the questions go. As I'm scrolling down, I did miss one at the top here. Let me grab that one real quick. Regarding moisture, is there a concern with excessive condensation due to the air tightness of the SIPs? Of course, yes, there's a concern. As we strive to build more and more energy efficient homes, we also have to think about how we control the inside air quality. This is always going to be more and more and more of a concern because codes are not going to make it less efficient, like our 1921 bungalow where the air would just flow in and out of the home. We're creating more efficient homes. With that becomes more air tightness, and with more air tightness means we need to mechanically control the inside air quality through pulling out moisture, through HEPA filters, that kind of thing. All right, Lori, I think that's it.
Okay, thank you all for attending.
Lori, I'm going to hit end.
Okay.
Okay.